Right now, 4 human beings are farther from Earth than any humans have ever been. You are sitting still. The air around you is calm. Whatever room you are in is quiet or close to it, and 252,756 miles away from where you are sitting, 4 astronauts inside a capsule called Integrity are hurtling back toward this planet at a speed that would carry them from New York to London in 8 minutes. You cannot feel them out there. There is no weight or pressure or signal you can detect that tells you this is happening. But it is happening. This is not a simulation. This is not a rehearsal. It is happening right now as you listen to this, and it is the first time it has been true of any human being since December 1972. For 54 years, no one went back. The Apollo program ended, the moon faded from the front pages, and the question of what was out there, really out there, on the surface and beneath it and on the side we never see, went largely unanswered. We sent robots. We mapped from orbit. We bounced signals off the regolith and measured seismic tremors from impact craters billions of years old. But we did not send human eyes. Human eyes are different from instruments. That is not sentiment. That is established science. The human visual system can detect subtle color gradations that cameras at this distance cannot resolve, can integrate multiple angles of illumination simultaneously, can identify anomalies that were not in the training data because nobody told the eye what to look for. When Apollo 12 astronaut Alan Bean returned from the moon, he became a painter specifically because of what he had seen up there. He said the moon was not grey, he said it was brown and tan and gold, and occasionally something close to blue. No photograph from orbit had shown that. It took a human being standing on the surface, or very close to it, to see it. On April 6, 2026, humans saw the moon properly for the first time since the last Apollo astronaut left, and what they saw is changing what we thought we knew. If this is the kind of investigation that interests you, subscribe now. The investigation begins here. To understand what just happened, you need to understand what the gap actually was. Apollo 17 lifted off the lunar surface on December 14, 1972. Geologist Harrison Schmitt and Commander Gene Cernan were the last 2 humans to stand on another world. When their ascent module docked with the command module above, and when they fired the engine that sent them home, that was it. That was the last time, for more than half a century. In the years that followed, the moon did not go unstudied. The Lunar Reconnaissance Orbiter has been circling the moon since 2009, mapping it in extraordinary detail. The LCROSS mission deliberately crashed a rocket stage into the South Polar region in 2009 and detected water ice in the plume. India's Chandrayaan-3 landed near the South Pole in 2023. China's Chang'e missions have returned samples. Japan's Slim Lander touched down in 2024. The moon has been explored in the sense that machines have been there, but machines are not the same as people. And this distinction matters for reasons that are both practical and deeply scientific. The practical reason is this: an astronaut with a camera and a trained eye can make real-time decisions about what to look at. They can deviate from the plan because something caught their attention. They can rotate slightly, crouch slightly, adjust the angle of illumination. A rover or orbiter is pointed at its targets in advance. The human is present. The scientific reason is more fundamental. The human brain is the most sophisticated pattern recognition system we have yet encountered. When Artemis II mission specialist Christina Koch looked at the moon's surface from inside the Orion capsule and reported that the fresh craters looked like a lampshade with pinprick holes, she was doing something no automated system could replicate. She was finding the right analogy. She was building the mental model, and that mental model, reported back in real time to scientists on the ground, is data. The gap was 54 years, and the gap mattered. The Orion capsule that carried the 4 Artemis II crew members was named Integrity by the crew themselves. That detail is small but not unimportant. It is a tradition going back to the earliest days of human spaceflight, when Mercury astronauts named their own capsules. Naming the vehicle is an act of relationship. You do not name something you are indifferent to. The crew consisted of Commander Reed Wiseman, a Navy test pilot and former commander of the International Space Station, pilot Victor Glover, a Navy aviator and the first black astronaut assigned to a lunar mission, mission specialist Christina Koch, who holds the record for the longest single spaceflight by a woman at 328 days and has conducted multiple spacewalks, and mission specialist Jeremy Hansen of the Canadian Space Agency, making him the first Canadian to travel beyond low Earth orbit. The Orion capsule itself is not small. It is the largest crew vehicle NASA has built since Apollo. The pressurized volume available to the crew is about 316 cubic feet. That is roughly the size of a large bathroom or a small walk-in wardrobe. 4 people, 10 days, 695,081 miles of total travel distance. The capsule has windows, real windows, not portholes, windows sized and positioned specifically so that astronauts can make visual observations of other worlds. The Space Launch System rocket that sent them there is currently the most powerful rocket ever to fly. Its main engines, combined with its solid rocket boosters, produce 8.8 million pounds of thrust at launch. To put that in terms you can feel, the equivalent of 160,000 car engines firing simultaneously. The ground shakes, the air shakes, the sound arrives as a physical thing. They launched from Kennedy Space Center on April 1st, 2026 at 6:35 in the evening, and the world watched. 54 years is long enough for an entire generation to have grown up with the moon as a destination rather than a memory. For people under the age of 50, no human being had ever in their lifetime left low Earth orbit. That sentence deserves to sit for a moment. No human being had in their lifetime left low Earth orbit. Then 4 of them did. The path to that April evening was not clean. The mission had been planned, delayed, replanned and delayed again multiple times over the course of years. The original expectation was a launch as early as 2023, then 2024, then September 2025, then February 2026. Then there was a liquid hydrogen leak during a simulated countdown, then a valve that required reattention, then a helium flow issue that sent the entire assembled rocket, the Space Launch System with the Orion capsule on top, rolling back into the vehicle assembly building on its enormous crawler transporter. Each delay was not a failure. Each delay was the system working as intended. The purpose of extensive testing before a crewed mission is to find every possible problem while the vehicle is still on the ground. The hydrogen leak was found, the valve was fixed, the helium issue was identified and resolved, the February window was missed. A new window opened in April, and on April 1st, the rocket stood on launch pad 39B, the same pad that launched the Saturn V rockets of the Apollo era, and the crew climbed aboard. There was also the heat shield question. The uncrewed Artemis I mission in 2022 had returned data showing that the heat shield, made of a material called AV coat, had experienced more erosion than the models predicted during re-entry. Some engineers felt this was serious enough to ground Artemis II until the shield was redesigned. Others felt the data supported flying with the existing design. The debate ran through 2025 and into early 2026. In January 2026, NASA Administrator Jared E. Zayakman reviewed the analysis, met with engineers and outside experts, and stated that he supported proceeding with the mission. Some participants who had expressed concerns said the additional data addressed their questions. Others continued to object. The mission flew with the existing heat shield and a modified re-entry trajectory, steeper than originally planned, that reduced the thermal load on the shield. The data from that re-entry, when Orion enters the atmosphere at 25,000 miles per hour on April 10th, will be the most important heat shield measurement yet obtained. That data will directly determine what changes are made to the Artemis III heat shield, which will have to survive a re-entry from a full lunar landing mission. This is how hard engineering decisions get made, not with certainty, with evidence, debate, and a final judgment call that someone has to make. The first day in space is not the dramatic part, it is the testing. The crew entered a high Earth orbit and spent several hours confirming that Orion's systems worked. Life support, navigation, power, propulsion. They practiced proximity maneuvers using the European Service Module's reaction control engines, simulating the docking approaches that future missions will need. They checked and double-checked. On the second day, they fired the main engine for approximately 6 minutes. This burn is called the translunar injection. It is the moment the mission changes character. Before the burn, the spacecraft is circling Earth. After the burn, it is leaving. The velocity increase is enough to break free of Earth's gravitational hold and begin the long fall toward the Moon. From the outside, this looks modest. The capsule accelerates by a few thousand kilometers per hour, But that acceleration, applied at the right point in the orbit, changes the entire trajectory. They were on their way. The journey from Earth to the Moon takes about 4 days in this trajectory. 4 days in a space the size of a large bathroom. The crew had 189 menu items available: tortillas, nuts, barbecue beef brisket, macaroni and cheese, butternut squash, cookies, chocolate. They had coffee, they had smoothies, they had a small food warmer. There is no refrigerator on Orion. Everything is either ready to eat or rehydratable. On day 4, Christina Koch looked out of one of Orion's windows and took a photograph of Earth. The photograph was released and became immediately famous. Earth appears in the image as a crescent because of the angle of illumination from the sun, and the image was taken with Orion rotated approximately 180 degrees from its standard orientation. Earth appears upside down. It is blue and white and impossibly fragile looking. The crew named the image Hello, World. There is something specific about photographs taken from an increasing distance. The Earth at 10 miles looks like Earth. At 100 miles it still looks like Earth. At 1,000 miles it begins to shrink. At 100,000 miles it is a bright dot with visible continents. At 200,000 miles it is smaller than your thumbnail held at arm's length. At 252,000 miles it is a marble. The Artemis II crew experienced that transition in real time over 4 days, and they described it in radio transmissions back to mission control. The Earth gets smaller, the Moon gets larger, and at some point, the Moon's gravity becomes stronger than Earth's. That point is called the lunar sphere of influence. They crossed it on day 5, quietly, without ceremony. One moment Earth was pulling harder, the next moment the Moon was. Here is a fact about the Moon that most people know but have never truly absorbed. The Moon always shows the same face to Earth. Always. The Moon rotates on its axis once per orbit around Earth, which means the same side perpetually faces us. This is not a coincidence. It is the result of tidal locking, a gravitational process by which Earth's pull gradually slowed the Moon's rotation over billions of years until it's synchronized. The same hemisphere has faced Earth since long before the first human beings existed. The far side of the Moon is not dark. That is a common misconception. It receives sunlight. What it never receives is a direct line of sight to Earth. No radio signal from Earth can reach it directly. No human eye from Earth has ever seen it. When the Apollo astronauts orbited the Moon, they passed over the far side in approximately 20 minutes per orbit, and they had limited time to observe it. The geometry of their orbits and the timing of their flights meant that certain regions were always in shadow or always at the wrong angle. The Artemis II mission had a different trajectory. Because of where the Sun, Earth and Moon were positioned on April 6, 2026, certain areas of the far side were illuminated at angles that had never previously been available to human observers. The science team had spent months calculating exactly which features would be visible, under what conditions, and for how long. They had compiled a list of 30 targets. They sent that list to the crew the day before the flyby. There were 3.8 billion-year-old impact basins. There were fresh craters with bright ejector rays still pristine enough to use as age markers. There were volcanic deposits and tectonic faults. There were regions so heavily pocked with impacts that the surface looks unlike anything else we've ever seen, a geological record of 4 billion years of bombardment preserved in stone. The crew memorized 15 key landmarks before launch. When they arrived, they recognized them. Kelsey Young, a planetary scientist at NASA's Goddard Space Flight Center and the lunar science lead for the Artemis II mission, had described the human eye as the most nuanced detector there is, especially when connected to a well-trained human brain. She said this before launch. The science results from the flyby confirmed it. 4 billion years ago, give or take, something hit the Moon. The object was approximately 40 miles wide. This is not speculation. This is what the geological record says. It struck the lunar surface with enough energy to melt the surrounding rock, send debris flying thousands of miles in every direction, and create a pressure wave through the crust that rippled outward like a wave in a pond. Except the pond was stone. The resulting crater is called Oriental Basin. It is nearly 600 miles across. It sits on the boundary between the near and far sides of the Moon, which means that from Earth, you can sometimes glimpse the outermost edge of it near the lunar limb, but only at certain angles of libration. The full structure, the 3 concentric rings of mountains that surround it like a bullseye. The innermost ring formed when the central peak collapsed. The outer ring formed when the molten debris wave froze in place, has never been visible to human eyes in its entirety. When the impact happened, scientists believe the debris wave was 11 times taller than Mount Everest. 11 times. That is a wave of rock 290,000 feet high, moving outward from the impact site and then sloshing back for 2 hours before freezing into the concentric mountain rings visible today. No human had ever seen the complete structure with their own eyes. Because it straddles the boundary between the near and far sides, the geometry is never right from Earth. The Apollo astronauts, whose orbital paths took them to different latitudes and whose missions had different lighting conditions, never had Oriental fully illuminated in their field of view. On April 6, 2026, Commander Reed Wiseman looked at it through Orion's window. He described the annular ring as a pair of lips on the far side of the moon. He said from orbit it looked far more circular than any training photograph had suggested. He said the northern part was darker and the southern part lighter. He said it was neat looking. That word, neat, is doing a lot of work. It is the word you use when you have just seen something so far outside your experience that the emotional processing has not caught up yet, and all you can manage is the plainest available adjective. Neat. Like when someone is handed the first photograph of a black hole and says it looks round. Oriental is not just impressive to look at, it is a scientific archetype. Scientists believe that impacts of this scale, large enough to excavate material from deep within the lunar interior and splatter it across hundreds of miles, are responsible for much of the moon's crustal structure. The material ejected from Oriental and distributed across the surrounding terrain contains rock from depths that would otherwise never be accessible. When future missions eventually land near the rim and collect samples, they will be collecting pieces of the deep lunar interior that the impact brought to the surface. This is confirmed science. The debris blanket from Oriental has been mapped from orbit. The mineralogy of the ejecta has been partially characterized by spectroscopy, but the real-time description from Commander Wiseman, the circularity, the contrast between north and south, the way it looked different from what the training photographs had suggested, added something that orbital instruments had not. It told the science team that the viewing geometry from the trajectory of integrity, the specific angle of illumination, and the specific distance revealed aspects of Oriental's topography in a way no orbital pass had previously captured. That information will be used to plan future observations and eventually to select landing sites in the region. The science team in Houston, in their newly established science evaluation room, a physical space created specifically for this mission, a recognition that science deserved its own seat at the table in mission control, had been waiting years for this moment. They heard Wiseman describe the basin, and, according to reports from observers in the room, it was very quiet. Victor Glover, the mission's pilot, became captivated by something that planetary scientists have known about but never heard described from direct human observation at lunar distances: the terminator. The terminator of the moon is the line between the illuminated and the dark portions of its surface. It is not a crisp edge. It is a gradient because the sun is not a point source of light but a disk, and at the boundary between lunar day and lunar night, the sun sits very low on the horizon, raking across the terrain at an angle that makes every feature cast an exaggerated shadow. This grazing illumination is what planetary geologists live for. Craters that are invisible in direct sunlight become obvious at the terminator because the shadow of one wall falls into the crater interior and the other wall is brightly lit. Mountain ranges that are barely perceptible otherwise suddenly become dramatic, ridgelines throwing shadows hundreds of miles long. Glover described the terminator as the most striking thing he had seen on the flyby. He said there were islands of light. He said the valleys looked like black holes where you would fall straight to the center of the moon. He described the magic of what light at that angle does to terrain and said it was just visually captivating. These descriptions were transmitted live to the science team. They were recorded. They are data. Because the human eye perceiving something at the terminator, with the brain attached making real-time assessments of shadow depth and contrast and the relative brightness of adjacent features, can estimate slope angles and surface roughness in ways that orbital radar cannot replicate exactly. The texture of language that Glover was using, islands of light, black holes, has geometric content embedded in it. This is not sentiment, this is science. Christina Koch, meanwhile, was making measurements. She observed that Earth and the Moon were visible simultaneously in Orion's windows, and that Earth appeared significantly brighter. She noted that this was not a focus effect, not an artifact of her eyes adjusting between two different distances. She said she and her crewmates were seeing both in the same field of view, and Earth's higher albedo was unmistakable. Albedo is the technical term for how reflective a surface is. It is measured on a scale from 0 to 1. Pure black absorbs everything, albedo 0. A perfect mirror reflects everything, albedo 1. Earth's average albedo is about 0.30. The Moon's average albedo is about 0.12. This means Earth reflects more than twice as much sunlight as the Moon. Scientists have known this from measurements for decades. Koch confirmed it with her eyes, from 250,000 miles away in real time. She said, "Since we are seeing both in the same field of view, we do think that this can be inferred as the Earth as a whole having a higher albedo. That is a scientific statement, made from a capsule window, by a person sitting 250,000 miles from home." She also reported something else. The more she looked at the Moon, she said, the browner and browner it looked. This is consistent with what Apollo astronauts reported. The Moon is not grey. It is a complex mix of tan and brown, and in some areas, something approaching blue-green. These subtle colour differences reflect the mineral composition of different surface regions, the ratio of iron to titanium in the basaltic rock, the age of the surface, the degree to which space weathering has processed the uppermost layer of regolith. Mission specialist Jeremy Hansen described a plateau on the far side as having unique greenish hues that he saw nowhere else on that side of the Moon. He said he did not see anything like that anywhere else. This is not casual observation. This is a trained geologist's eye on a surface 4,000 miles away, identifying a spectral anomaly that the training photographs had not flagged. The science team will spend months comparing his description to spectral data from orbital instruments, trying to determine what mineral assemblage could produce that specific colour at that specific location and illumination angle. The greenish hue in that specific area might indicate the presence of a particular silicate mineral, or it might indicate something else entirely. The observation is the beginning of an investigation, not the end of one. 40 minutes. When Integrity passed behind the Moon, Mission Control lost contact. There is no way around this. The Moon itself blocked the radio signal. The Deep Space Network, a global array of enormous dish antennas that maintains contact with spacecraft throughout the solar system, simply could not reach through the Moon to find Orion on the other side. For 40 minutes the crew was unreachable. This happens during every lunar mission. It happened during Apollo. The astronauts knew it was coming, prepared for it, and used the time. They gathered in the cabin. Each of them took a maple cream cookie from the Canadian astronaut's supply. They ate for about 30 seconds, and then they went back to work. When Integrity emerged from behind the Moon, something unexpected in its scale and duration began: a total solar eclipse. From the perspective of the capsule, the Moon had moved between Orion and the Sun. The Sun disappeared behind the lunar disk. The corona, the Sun's outermost atmosphere, began to glow around the edge of the Moon. Here is what makes this different from any solar eclipse observable from Earth. From Earth, a total solar eclipse lasts a maximum of 7.5 minutes. This is because the Moon moves across the Sun relatively quickly from our perspective. But from Integrity's position, far from Earth, at a different geometry entirely, the eclipse lasted 57 minutes. 57 minutes of totality. In those 57 minutes, the crew made observations that no human being had ever been positioned to make. They observed the solar corona in unprecedented detail. The corona is the Sun's outermost atmosphere, a plasma extending millions of miles into space, typically visible from Earth only during brief totalities and always obscured by atmospheric scatter just outside the totality zone. From Integrity, with no atmosphere between the crew and the corona, and with nearly an hour of observation time, the view was different from anything previously recorded by human eyes. Stars and planets became visible alongside the corona. Venus was there, Mars was there, Saturn and Mercury. The same sky that ancient astronomers catalogued from Earth, seen from a point 250,000 miles farther away, without the filtering of any atmosphere. And then they started counting. In the shadow of the Moon, looking at the dark portion of the lunar surface, the crew saw flashes, brief, tiny, distinct points of light appearing momentarily on the dark lunar surface and then vanishing. 6 of them. These are impact flashes. They occur when a meteoroid, a small piece of rock or ice travelling through space, strikes the lunar surface. The impact releases enough energy to briefly vaporize rock and create a flash of light. These flashes have been detected from Earth by automated telescope systems. During the Apollo 17 mission in 1972, astronaut Harrison Schmitt observed impact flashes from lunar orbit on 3 separate occasions. But the viewing conditions from Integrity, with 57 minutes of totality and a clear dark surface visible below, were far better than anything previously available. The crew saw 6 in 57 minutes. That is a measurement. That is data that will be cross-referenced with ground-based observatories and used to refine models of the current lunar impact rate. Understanding the current rate of meteoroid bombardment of the Moon is directly relevant to understanding how quickly the lunar surface degrades, how long instruments and habitats placed on the surface will last, and what protective measures will be required for the astronauts who will eventually live there. 57 minutes, 6 flashes, 6 tiny impacts, each one a piece of the solar system hitting the surface of another world, observed for the first time in history by human eyes positioned exactly where they needed to be positioned to see them. Both Wiseman and Hansen, during a post-flyby debrief, described the flashes as a momentary pinprick of light. They could not determine how long each one lasted. That is fine. The fact of 6 independent impacts in 57 minutes is the number that matters. The detail will be refined by analysis. There is a specific place on the Moon where NASA intends to land the Artemis II crew sometime in the next few years, the South Pole. The South Pole of the Moon is not like any place humans have landed before. The 6 Apollo landing sites were all in the middle latitudes of the near side, in relatively flat regions of ancient volcanic basalt called mare, chosen specifically because they were flat and safe and reasonably well mapped. The South Pole is none of those things. The South Pole is a region of extreme topographic relief, ancient craters so deep that their floors have not seen sunlight in billions of years. These permanently shadowed regions are where radar and neutron detectors have found evidence of water ice, deposited by comets and asteroids over geological time and preserved by the permanent cold of the shadows. The temperature at the bottom of these craters is approximately -250 degrees Celsius. At that temperature, water ice brought there by impacting comets billions of years ago has simply stayed. It has never had a reason to leave. Water ice at the lunar South Pole is not a minor scientific curiosity. It is potentially one of the most valuable materials in the solar system for the purposes of human expansion beyond Earth. Water can be split into hydrogen and oxygen by electrolysis. Oxygen for breathing, hydrogen for rocket fuel. A water source at the South Pole is potentially a refueling station for missions deeper into the solar system. You extract water, split it, compress the gases and fill your tanks. The Moon as a way station. This is not distant speculation. It is the stated strategic rationale for the South Polar Landing Program, and it is backed by measured data showing water signatures from multiple independent instruments. But to land there safely, to traverse the terrain, to extract what is there, requires knowing the terrain in detail that current orbital data does not fully provide. Orbital radar can tell you slope angles and surface roughness to a certain resolution. It cannot tell you what traversing that terrain feels like to a trained observer looking at it. Victor Glover looked at both poles during the flyby. He described the South Pole as showing quite a bit of elevation change. He said it seemed more jagged and more challenging than the North Pole. He said that finding a place to land and to traverse in the South Polar region would be genuinely difficult. Kelsey Young, the lunar science lead, had specifically asked Glover to compare the topography of the North and South Poles. She knew the South Pole was the landing target. She wanted the human assessment. This description matches orbital data, but it also fills in something orbital data cannot. The sense of scale and relief that a human visual system trained over decades of looking at terrain automatically extracts from a view. Glover's eyes were integrating the shadows and highlights and topographic cues in a way that produced a direct assessment. Challenging, jagged, quite a bit of elevation change. The Artemis III crew training right now for a South Polar landing will receive this description. They will use it alongside the orbital maps, the radar profiles, the photographic surveys. The astronaut who looks at the terrain from inside the capsule and says more jagged than the North Pole is giving them something no orbital map conveys with the same immediacy, and the permanently shadowed craters themselves, the ones that hold the ice, were visible from Integrity as a region of absolute dark within the bright polar terrain. Glover could see which craters were in perpetual shadow. He could see the scale of the darkness. That observation, transmitted back to Houston, adds a human dimension to a dataset that has previously existed only as numbers and false colour maps. During the flyby, while setting the distance record and conducting the science observations, and watching the solar eclipse and counting meteoroid impacts, the crew looked out the windows and saw something else. Two small, previously unnamed craters. The first was northwest of the Oriental Basin on the far side. The crew looked at it, discussed it with the science team, and proposed a name, Integrity, after the capsule. The second was on the boundary between the near and far sides, a position from which it is sometimes visible from Earth. This one they proposed naming Carol, after Commander Reed Wiseman's wife, Carol Taylor Wiseman, who died in May 2020. These proposals will be formally submitted to the International Astronomical Union, the organisation that governs the naming of celestial bodies and their surface features. The names have not yet been officially approved, but the craters now have names in the minds of the people who found them and in the minds of everyone who will read about this mission. There is something worth sitting with in that. Human beings, farther from Earth than any humans had ever been, looked at a piece of geological terrain that has sat there unchanged for billions of years and gave it a name that carries grief in it. Carol, named for someone who did not get to see this day. The Orion spacecraft named Integrity flew past the crater now called Integrity. That alignment was not planned. The naming happened in the moment spontaneously because the crew saw two small unnamed craters and asked the science team if they could name them. The science team confirmed the locations. The names were proposed over the radio. The Moon has always been a surface that humans have given names to. Every major crater visible from Earth has been named. Most of them are named for scientists and scholars: Copernicus, Tycho, Kepler, Plato. But some are personal. Some carry the weight of specific human lives. Carol will be there, on the boundary between the side we always see and the side we never see, for as long as the Moon exists. Before this mission, the crater now called Carol had sat on that boundary, 4.5 billion years old, visited by no one, named by no one. Now it has a name. That name will be submitted to the International Astronomical Union. Future lunar maps will mark it. Future astronauts, training for missions to the near-side/far side boundary, will see it listed in their briefing materials and know that someone looked at it once from a passing capsule and gave it the name of someone they lost. That is not science. That is something else. Something that has been part of human exploration since the first person climbed a hill and named what they could see from the top. At 1:57 in the afternoon on April 6th, 2026 Eastern Time, the 4 crew members of Artemis II became the humans who had travelled farther from Earth than any other humans in history. The previous record was held by the crew of Apollo 13. This is worth a moment. Apollo 13 set its record not by intention, but by accident. In April 1970, an oxygen tank in the service module exploded 2 days into the mission. The planned lunar landing was aborted. The crew had to use the lunar module as a lifeboat. Their emergency trajectory sent them swinging around the far side of the Moon at a distance, 248,655 miles, that no human had reached before and no human had reached since. That record stood for 56 years. The Artemis II crew surpassed it by 4,101 miles. Their maximum distance was 252,756 miles from Earth. In the time it would take you to drive from one end of a large city to the other, they were farther from every person you know than any human being had ever been. Jeremy Hansen, the Canadian astronaut, spoke at that moment to Mission Control and to the world. He said that humanity had once again shown what we are capable of. He said it was the hopes of the world for the future that carry us now on this journey around the Moon. He was speaking from a capsule 252,000 miles away. The signal carrying his voice travelled at the speed of light. It still took 1.35 seconds to arrive. That pronoun matters. Not I, not we four, but us. The pronoun expansion was not rhetorical. He meant it literally. 4 people went. The species sent them. Every person who built a component of the space launch system, every person who trained these crew members, every person who watched the launch and held their breath is implicated in that distance record. A recording had been made before the mission by the late Jim Lovell, who died in 2025 at age 97. Lovell had flown on Apollo 8 and Apollo 13. He had been to the moon twice. He recorded a message for the Artemis II crew to hear on the morning of the flyby. "Welcome to my old neighbourhood," he said. "When Frank Borman, Bill Anders and I orbited the moon on Apollo 8, we got humanity's first up-close look at the moon and got a view of the home planet that inspired and united people around the world." He said he was proud to pass that torch. He said, "Don't forget to enjoy the view." Commander Wiseman, hearing this message from a man who died before he got to hear how it was received, said it was an awesome message. He said it was very cool to hear Lovell welcome them to the neighbourhood. There is a chain here, a chain of people who have been to that neighbourhood, and the much longer chain of people who sent them. The chain goes back to the first launch in 1961, and forward to missions that have not yet been planned. Lovell passed the torch to people he would not live to see use it. Here is something that is both technically elegant and philosophically interesting about the Artemis II trajectory. After the translunar injection burn sent them toward the moon, and after they swung around the far side at their closest approach of 4,067 miles, the spacecraft did not need to fire its engine to come home. This is called a free return trajectory. The orbital mechanics are such that if Orion had simply done nothing after the translunar injection, the moon's gravity would have bent its path into a curve, slung it around the far side and sent it back toward Earth on a trajectory that would return it to the vicinity of Earth without any further propulsive maneuvers. The path is essentially a figure 8, using the moon as a gravitational pivot. The capsule fires one engine burn to leave Earth's orbit. After that, physics carries it home. This was not always the plan. Earlier versions of the Artemis II mission called for a skip re-entry, a maneuver in which the capsule briefly dips into the upper atmosphere, generates lift like a stone skipping off water, and uses that lift to extend the glide path and improve landing precision. The skip re-entry was abandoned after the uncrewed Artemis I mission revealed heat shield erosion that was not fully understood. Engineers examined the data, modelled the problem, debated its severity, and ultimately decided to fly a steeper, more direct entry profile for Artemis II. The heat shield question matters enormously for everything that comes after this. Orion is designed to carry astronauts on much longer missions than a 10-day flyby. Future missions will land on the moon and return, requiring entries at even higher energies. The entry at the end of Artemis II will happen at 25,000 miles per hour. That is the fastest crewed re-entry ever attempted. The heat shield data from that event will be the most critical measurement of the Artemis program so far. The free return trajectory in the meantime provided a margin of safety that the Apollo 13 crew would have been grateful for before the accident that made their trajectory famous. If Orion's engine had failed entirely after the lunar injection burn, the crew would still have come home. The moon's gravity would have carried them. This is not an accident of design. This is what careful engineering looks like. Every possible path home was calculated before launch. The free return trajectory was selected specifically because it preserved an abort option that did not depend on the engine firing again. To understand why any of this matters, you have to think briefly about what the moon actually is. The moon is approximately 4.5 billion years old. It formed, the current scientific consensus holds, when a Mars-sized body called Theia collided with the early Earth approximately 4.5 billion years ago. The impact was not a gentle one. It was catastrophic enough to melt both bodies, splash enormous quantities of material into orbit, and allow some of that material to coalesce under its own gravity into the moon. This is called the giant impact hypothesis. It is the best supported explanation we currently have for the moon's existence, its composition, and its orbital relationship to Earth. It is not speculation. The evidence comes from the isotopic ratios of lunar rocks returned by Apollo, which match Earth's in ways that would be statistically improbable if the moon had formed elsewhere. It comes from the moon's relatively low iron content, consistent with it having formed primarily from the mantle of the colliding bodies, rather than their cores. It comes from orbital modelling, that shows how the initial impact debris could have settled into a stable orbit and accreted into the object we observe today. The Moon is, in the most literal sense, a piece of Earth, but the Moon and Earth have had very different histories since that initial formation. Earth has plate tectonics, an atmosphere, water, life, and all the geological processes that these systems drive. Earthquakes, erosion, deposition, mountain building. The surface of Earth is in constant motion. Rocks from 4 billion years ago are exceedingly rare on Earth because most of them have been recycled through the mantle or eroded away. The Moon has none of this. The Moon stopped being geologically active in any significant sense roughly 3 billion years ago. Its surface is a frozen record of the solar system's early history. Every crater visible on the Moon is a scar from a real event. Every mountain range is the frozen rim of an ancient impact. Every lava plain is the result of volcanic eruptions that happened billions of years before the first complex organisms appeared on Earth. When Wiseman and Koch and Glover and Hansen looked at the Oriental Basin from inside Integrity, they were looking at something that formed 3.8 billion years ago. The wave of rock that froze into those concentric mountain rings froze 3.8 billion years ago. The surface of the Moon has been sitting there, essentially unchanged, for a time so long it defeats intuition. Earth was covered in microbes at the time, then it was covered in slightly more complex microbes. Then eventually, after another 3 billion years, the first animals appeared. And during all of that, the Oriental Basin was just sitting there, exactly as the crew saw it, waiting. This is the thing about the Moon that the Artemis II observations bring into focus. We've been looking at a geological archive for the entire history of human civilization without being able to read it properly. Not for lack of intelligence, for lack of access. The Moon is right there, 238,855 miles away, visible to the naked eye, closer than some of our satellites, and for 54 years no human being went to look at it up close. Now 4 of them did, and they came back with observations that will take years to fully interpret. There is something about the Moon that the Artemis II observations sharpen. The Moon's 2 faces are dramatically, unmistakably different from each other. The near side is partially covered by the dark volcanic plains called Maria. These plains formed when ancient volcanic eruptions filled large impact basins with basalt that welled up from the lunar interior. They make the near side of the Moon look mottled and varied, the light-coloured ancient highlands punctuated by dark flat seas. The far side has almost none of this. It is uniformly battered, heavily cratered, without the large, smooth volcanic plains. Its crust is thicker by approximately 10 to 15 kilometers. Its surface looks different. Its history looks different from almost every angle. Scientists have been arguing about why the 2 hemispheres are so different for decades. The leading hypotheses involve the distribution of heat-producing radioactive elements in the early lunar crust, which may have been concentrated on the near side, causing greater melting and volcanic activity there, or tidal heating from the early Earth when the Moon was much closer and the tidal forces were more intense, or a large secondary impact on the far side, perhaps even a second, smaller moon that eventually merged with the primary Moon and formed the thick far side crust. None of these explanations is fully satisfying. Each one explains some aspects of the asymmetry and fails to explain others. The images and observations from Artemis II will feed directly into these debates. The colour differences that Koch and Hansen described, the greenish hues in specific far-side locations, the relative darkness and brightness of different terrain types, the comparative appearance of near-side and far-side crater morphology as described in a real time by trained observers at close range, all of this is new information. Not definitive answers, new information. Science rarely produces definitive answers on its first pass. It produces increasingly constrained uncertainty. The range of possible explanations for the near-side/far-side asymmetry is going to get slightly narrower as a result of what was seen on April 6, 2026. The anomalous greenish region that Hansen described is a potential clue whose significance will only become clear once the spectral data from orbital instruments is cross-referenced with his description and the imagery the crew took. That is how science works. An observation gets made, a question gets sharpened, An investigation begins that may not conclude for years. On the 7th day of the mission, Orion and the International Space Station had a conversation. This is worth noting because of the geometry involved. The ISS orbits Earth at an altitude of approximately 250 miles. Orion, on day 7, was approximately 230,000 miles from Earth, heading home. They were 230,000 miles apart. And they talked for 15 minutes over a radio link that required no relay station and no special equipment beyond the Deep Space Network dishes already tracking both spacecraft. The call was practical in origin. It had been planned before launch. Part of the mission flight plan included this communication as a test of long-range crew-to-crew contact protocols. But the content was human. They discussed food. European Space Agency astronaut Sophie Adenauer told the Artemis II crew she had mango salad for breakfast and asked if they had it on board. Commander Wiseman described their menu. The ISS crew congratulated the Artemis II crew on the flyby and the distance record. The Artemis II crew congratulated the ISS crew on their ongoing mission. Everyone was polite and sincere and slightly surreal. ISS Commander Jessica Meir, the most experienced current astronaut in orbit, wished the Artemis II crew a safe return. The significance underneath the pleasantries is worth stating clearly. At the moment of that call, there were 11 human beings in space simultaneously. 4 beyond the Moon's orbit, on their way back from the farthest point any human had ever reached. 7 others in low Earth orbit, 250 miles up, doing the continuous lower drama work of the space station. Experiments, maintenance, exercise to prevent the bone and muscle loss that weightlessness causes. 11 people in space at once. This has never happened before in this configuration. There have been humans in space almost continuously since November 2000, when the ISS was first crewed. But humans beyond low Earth orbit, simultaneously with humans in low Earth orbit, has not happened since the Apollo era, and never quite like this. The ISS did not exist during Apollo. 4 of those 11 people were so far away that their voice signals took over a second to arrive. The other 7 were closer to your home, right now, than the distance from London to New York. The mango salad detail is not trivial. The mango salad is the evidence that this has become, in some sense, ordinary enough to be discussed casually. Not easy, not without risk, but ordinary enough for small talk about breakfast. That shift from extraordinary to ordinary is what preparation for genuine multi-world civilization looks like in its early stages. You do extraordinary things until they are boring enough to discuss over a 15-minute scheduled call. Orion will splash down in the Pacific Ocean near San Diego on April 10th, 2026. Recovery teams from the US Navy will retrieve the capsule. The crew will be medically evaluated. They will be flown to Johnson Space Center in Houston, and then the work begins. The data from the mission will take years to fully analyze. The images from the far side flyby are not all even transmitted yet. There is more imagery on board Orion than could be downlinked during the mission, and it will continue to be processed after splashdown. The descriptions that Koch and Glover and Hansen and Wiseman made of specific features, transmitted in real time, will be matched against orbital datasets from the Lunar Reconnaissance Orbiter and cross-referenced with spectral data from multiple instruments. The 6 meteoroid impact flashes will be logged against automated impact monitoring networks. The solar corona observations will be compared with data from space-based solar observatories. None of this produces immediate headlines. This is how science works. The headlines come when humans go somewhere for the first time in 54 years. The understanding comes later, slowly, in papers, in conferences, in the revised models that appear 3 or 5 years from now in journals that most people will never read. But Artemis III is already being planned. The crew is already training. The target is the South Polar region, where the permanently shadowed craters hold the ice, where the terrain is as Glover described it, jagged and dramatic and challenging. This mission will carry humans to the lunar surface for the first time since 1972. They will not just fly past, they will land, they will step out, they will pick up rocks and carry them home. The south pole of the Moon is not like any place humans have visited. The ice deposits there, if they are as substantial as some measurements suggest, represent a genuinely new category of resource for human exploration beyond Earth. Artemis IV is being planned for early 2028, and missions after that will begin the construction of what NASA is calling a moon base, a long-term human presence on the lunar surface. The destination beyond that is Mars. The moon is the rehearsal, not a metaphorical rehearsal, a literal one. The systems, the life support, the power generation, the navigation, the long-duration spacecraft design, the communication protocols, all of these need to work perfectly on the moon before they are trusted to work on a mission that takes 9 months to arrive at its destination and cannot be aborted. Artemis II was the first step in that rehearsal. The heat shield that will re-enter the atmosphere on April 10th at 25,000 miles per hour will give engineers the data they need to build the next heat shield, the one that carries the Artemis III crew back from the surface. The trajectory data, the life support data, the communications data, the human health data from 10 days in deep space. All of it feeds into the design of the missions that follow. The crew have plenty to pass on, Glover said, to the Artemis III crew. That phrase, plenty to pass on, is the grammar of an ongoing program. Not a stunt, not a demonstration, but a program. A sequence of missions, each learning from the last, each making the next one safer and more capable. There is a photograph that exists taken on April 7th, 2026, after the flyby was complete and Orion was on its way home. The photograph shows a muted blue Earth. It appears over the rim of the cratered moon, rising from behind the dark grey lunar horizon, in a composition almost identical to the famous Earthrise photograph taken by Apollo 8 astronaut William Anders in December 1968. Almost identical, but not the same. The 1968 photograph was taken from lunar orbit, much closer to the moon. The 2026 photograph was taken from a point more than 4,000 miles farther out. The Earth in the 2026 image is slightly smaller, and on Earth's day side, visible through the swirling white clouds, you can make out the region of Australia and Oceania. You can see the geography of the Pacific. You can see, if you know where to look, the approximate location of the ocean where, in a few days, Orion and the 4 people inside it will hit the water at 25,000 miles per hour, and the parachutes will open, and the capsule will bob on the surface and the Navy helicopters will come. The images the crew sent back were described by NASA Science Associate Administrator Nikki Fox as so exquisite and brimming with science, they will inspire generations to come. That is the language of press releases. But behind the language is something real. The images show geological features that no orbital instrument had captured from the same angle at the same illumination. The corona photograph with the dark disk of the moon surrounded by the glowing outer atmosphere of the sun is among the clearest images ever taken of solar corona structure from a position in space. The images of the far side, with Earth visible in the background behind the battered, crater-scarred terrain, are images of something that has existed for 4.5 billion years but was never photographed from this angle by a camera held by a person. The mascot flying inside the cabin during the mission was named Reese, inspired by the Earthrise photograph from Apollo 8, designed by an 8-year-old named Lucas Yeh from Mountain View, California. It was selected from more than 2,600 submissions from over 50 countries. It depicts the moon wearing Earth as a baseball cap. It was fabricated by NASA and tethered inside the crew cabin, where it floated in microgravity for the duration of the mission. A small stuffed toy tethered inside the capsule, travelling 252,756 miles from the child who designed it, while the moon it rides on wears the Earth like a hat. This is the distance we have come. The moon is, at this moment, 238,855 miles from where you're sitting. It has been there for 4.5 billion years. For the first 53 years of the space age, we went there and came back and then stopped. We built robots and sent them instead. We mapped from orbit. We planned and delayed and planned again. There were budget constraints and political decisions and engineering problems that took years to solve, and a heat shield debate that almost delayed the mission by another year. And then this week, we went back. 4 people, in a capsule named Integrity, became the most distant humans in history, and looked at a 3.8 billion-year-old impact basin with their own eyes, and said it was neat, and counted meteoroid impacts in the shadow of a total solar eclipse that lasted 57 minutes. and named a crater for someone they loved, and took a photograph of Earth rising over the moon that will be studied by scientists and looked at by schoolchildren for decades. The instruments will tell us what they saw in precise measurable terms. The numbers will get refined. The models will get adjusted, the papers will be written, but right now, as Orion descends toward the Pacific carrying the 4 people who have been farther from you than any humans have ever been, what is true is simply this. We are a species that looks up. That has always been true, but occasionally, and only occasionally after long gaps that are longer than they should be, we also go. The instruments are being built, the missions are being planned, the next crew is training, and you are living in the moment when, after 54 years of stillness, it started again. The investigation is ongoing, and we are the species doing it. There is one more thing the Artemis II mission is measuring that has nothing to do with the moon. The 4 crew members are themselves the experiment. Human beings evolved on the surface of Earth, specifically on the surface of Earth within its protective magnetosphere, the bubble of magnetic field generated by the planet's liquid iron outer core that deflects most of the high-energy particles streaming outward from the Sun and inward from the rest of the galaxy. Inside the magnetosphere, the radiation environment is manageable. The ISS orbits within the magnetosphere. Every human being who has been to the ISS has been inside that protective bubble. The moon is outside it. Beyond roughly 40,000 miles from Earth, in what is called deep space, the radiation environment is different. Charged particles from the Sun, called solar energetic particles, and from distant supernovae and other extreme events, called galactic cosmic rays, travel through this region freely. They are not deflected. They pass through spacecraft walls, they pass through human tissue, they interact with the atomic nuclei in cells. This is not an imaginary risk. It is measured directly. The Apollo astronauts received radiation doses during their missions that were higher than what ISS crews receive. The Apollo 14 mission in particular flew shortly after a major solar energetic particle event, and the crew received doses that would today exceed the recommended exposure limits. The astronauts were not told this until long after the mission. We now know more. The Artemis II crew is wearing dosimeters, instruments that measure cumulative radiation exposure with precision. Those measurements will add 10 days of deep space radiation data to a human dataset that currently has only 12 brief Apollo missions in it. The total duration of human deep space exposure in the entire history of spaceflight before Artemis II was less than 30 days across all 12 Apollo missions. Artemis II nearly doubles that figure. The radiation data will be used to refine the models that protect future crews. NASA has established radiation exposure limits for astronauts, measured in units called millisieverts, and the design of future missions, the shielding on future capsules, the protocols for sheltering in place during solar particle events, all depend on having accurate measurements of what the deep space environment actually delivers to human bodies. Christina Koch holds the record for the longest single spaceflight by a woman. She knows better than almost anyone what extended microgravity does to the human body. Bone density decreases, muscle mass decreases, fluid shifts toward the head. The eyes change shape from the internal pressure changes. The immune system behaves differently. These effects have been studied intensively aboard the ISS, and countermeasures have been developed. Structured exercise regimens, nutrition protocols, resistance training, fluid management. But 10 days in deep space is different from 10 days on the ISS in ways that go beyond radiation. The psychological environment is different. The ISS has a visual connection to Earth through its windows. Earth is close. Earth is enormous in the view. Earth is the thing you come back to in a few months. From integrity, Earth was a marble. The psychological data from Artemis II, the crew's reported experiences, their sleep quality, their stress responses, their cognitive performance on the test they conducted during the mission, adds to a very thin data set of what human minds do when Earth is that small and that distant. The next mission that puts humans this far from home will be a Mars transit. That will take 9 months each way. The psychological baseline established by Artemis II is one of the data points that will inform the crew selection, training and support systems for that mission. Victor Glover said, "Humans probably have not evolved to see what we are seeing." He was speaking about the simultaneous view of Earth and Moon from 250,000 miles. But he was also, without meaning to, making a biological observation. The human nervous system was shaped by tens of thousands of years of evolutionary pressure on the surface of one particular planet. The visual system evolved to perceive the distance range of that planet's surface. The threat detection system evolved to identify the predators of that planet. The emotional architecture evolved around a social world of a few hundred people visible at any one time. None of that evolutionary history prepared the nervous system for what the Artemis II crew experienced. And yet they went, and they came back, and they described what they saw with the precision and calm of people doing a job they had trained for. That is its own kind of data. The data of human adaptability. The data that says, this is strange and we can do it anyway. The south pole of the moon is waiting. Mars is waiting. The permanently shadowed craters with their ice are waiting, exactly as they have waited for billions of years. We are building the instruments to read the archive. We are sending the eyes to see the terrain. We are measuring the bodies that will have to survive the journey. The investigation continues, and we are the species doing it.